All right, what's up? It's your old pal, Mr. Cook, and we are going to work on 3.3, the odd problems. Okay, so this is adding and subtracting rational expressions. The first thing that you need to know is that you need to understand how to factor quadratics, cubics, just polynomials in general. So factor first or fail. Make sure you know how to do that. Okay. So factoring is going to really help you out in the case of rational expressions, when you're adding, subtracting, multiplying, simplifying, all that stuff. So in the case of adding and subtracting rational expressions, you need to know how to find the common denominator of a fraction. And so all of these adding and subtracting rational expressions work the exact same way as adding fractions together. So let me go through that real quick. If I had two fractions that I needed to add together, like 1/4 and 1/3, I couldn't just simply add the numbers together. What I need to do is find the common denominator first. So kind of like a jailbreak way of doing it is to just multiply the denominator of one onto the numerator and denominator of the other fraction, and do the same thing with the other one. So multiply this denominator and the numerator and denominator. The reason we have to do both, the numerator and denominator, is because 3/3 is 1, so it's not really changing anything. It's just multiplying by 1, so that doesn't change the fraction ultimately in the long run. But once you multiply fractions together, you do just multiply straight across the top and straight across the bottom. So 3 times 1 is 3, 3 times 4 is 12, 1 times 4 is 4, 3 times 4 is 12. Now that they have the common denominator, we just add across the numerator. It's only adding across the numerator that we do, okay? So we do 3 plus 4, and then the denominator stays the same, so it's still just 12, because once you find the common denominator, you don't have to do anything with it. So then you just add 3 plus 4 is 7, so 7/12 is our answer for the initial addition that we wanted to do, 1/4 plus 1/3. So we're going to do that same algorithm, but with fractions of rational expressions. Luckily for the first, 1, 2, 3, 4, 5 problems, they have the same denominator, so we don't have to do any of that common denominator stuff. So let's see how that looks when you don't have to do common denominator. When I'm adding two fractions together and they have the same denominator, I just simply add across the top. That's it. So the denominator stays the same, 24u squared v squared. And then we combine like terms. So it's going to be 6u plus u. So 6u plus u is going to give me 7u. And then 3v plus 6v is going to give me 9v. So plus 9v. Now when I'm simplifying expressions, rational expressions, this is when I'd want to factor. But if you notice, the only things that I could cancel out or factor would be prime numbers, and then also like if I try to divide out a u, I'd have to divide out a u from this and also from this, so that's not happening. And if I want to divide out a v, there's no v in this expression, so I wouldn't be able to do that. So this is the simplified expression when it's all done. These have common denominators already, so I'm going to be subtracting these two fractions. So the common denominator stays the same, 8x to the 4th, and then I have 5x minus 4y, and then minus 6y. So combining like terms, negative 4y and negative 6y gives me negative 10y, so I've got 5x minus 10y all over 8x to the 4th power. And that's as simplified as it gets, because I can't divide anything from 5, 10, and 8 at the same time. And not all of these have x's that I can cancel out. Like this one doesn't have an x, for example. So it just is what it is. Again, common denominator, so I'm going to just combine like terms. So same denominator in the bottom, 30x squared y squared. Then I have 3x minus 6x. So 3x minus 6x gives me negative 3x. Then I have 2y minus negative 2y. Well, let's reevaluate this. 2y minus a negative. Minus a negative should turn into a plus. So this is really saying 2y plus 2y, which would give us 4y, positive 4y. And under the same circumstances as the previous problem, 3, 4, and 30 don't have any common factors, and then not everything has an x and not everything has a y. So this is our simplified expression. Number 7, same denominator. So just, combine them together. So we've got 25r squared minus 10r. And then we have r plus 4r, which would be 5r. And then negative 4 plus nothing. So it's just going to be negative 4. And then, you can try and factor the bottom part, see if it, will factor anything out from the top. So let's see if that helps at all. So 5r minus 4. And then if I factor out, let's see here, 25 and 10 have a 5 that I can take out. And then r squared and r both have an r. So I'm going to divide out 5r from everything. 25r squared divided by 5r is 5r. Negative 10r divided by 5r is negative 2. So it doesn't look like I can simplify this because it would have to be 5r minus 4 to divide out, but it's 5r minus 2, so I can't really do anything about it. So this is my simplified expression. So yeah, I factored it. It didn't work, but at least I know that it won't, factor any further or, simplify any further. All right, next problem that I have has common denominators again. So that stays the same, 4n squared plus 8n. And then in the top, I have not n plus no other n, so it's just n. And the negative 6 plus 4, which would be negative 2. Now I'm going to try and factor out as much as I can from the bottom part. So let's see here. Looks like 4n squared and 8n both have a 4 that I can divide out because 4 and 8 are both divisible by 4. So 4 gets divided out. And then n squared and n both have n, so I'm going to factor out an n as well. So that means I get, let's see, 4n squared divided by 4n is just simply n. 8n divided by 4n is 2, so plus 2. And then in the top I have n minus 2. So again, it's really close, but these won't cancel out because this is a minus and this is a plus 2. So this is my simplified expression when I'm all done. Okay, number 11. So for number 11, these don't have the common denominator. So I need to do this trick that I started off doing at the very beginning of finding the common denominator. So I multiply this fraction by this one's denominator. So I need to multiply by 3x in the top and 3x in the bottom. Now I'm going to take this fraction and multiply by this one's denominator of 2. So I multiply by 2 in the top and 2 in the bottom. So I just multiply straight across. 3x times 5y is going to be 15 because that's 3 times 5. And then x times y is just xy. And then in the bottom, 3 times 2 is 6. So I got 6x in the bottom. And then let's see here. I've got 6x times 2, which is 12x. And then 6x in the bottom. And then I'm going to add across the top, so we've got 15xy. And then, since there's not an xy here, it's just going to be plus 12x. And then that whole thing is over 6x. All right, let's try and simplify some stuff. Well, 15, 12, and 6 are all divisible by the same number, and that's 3. So I'm going to divide all those by 3. 15 divided by 3 is 5. 12 divided by 3 is 4, so plus 4x. And then 6 divided by 3 is 2, so 2x. And then 5, 2, and 4, you can't divide anything else out of those. So that's it for the numbers. But then look at the variables. Every one of these has an x on it. So I'm going to divide out one x from each of these, and I get the following. 5y. And then the 4 divided by the x, so the x goes away, so it's just plus 4. And then the denominator, if I get rid of the x, it's just left with a 2, and that's it. So 5y plus 4 over 2. And that's the first page. That's where I'm going to stop this video. Then we'll start up on the odds for 3.3 on the backside in the next video.